Hey, this is WA4MCM from WA4MCM Kits, and in this video I'm going to demonstrate some of the soldering techniques used when assembling the RAS4 remote antenna switch kit. I'll also be giving you an overview of some of the tools that I use, as well as some tips and tricks that I use when soldering to help you get the best results. You can also use these techniques for just about any soldering task, including the assembly of my other kits. For all of my soldering, I've more or less settled on this Weller soldering station that you see here. It has precise temperature control, a bunch of different tips, and this cage that'll keep your soldering iron safe from things falling on it and getting burnt. It also comes with this little cleaning sponge, but I rarely use it for reasons that I'll explain in a moment. Personally, I found that around 340 degrees centigrade is a good temperature for all-around soldering. I use the Kester 6337 tin lead solder, and it seems to have a really good melting point at right around this temperature. There are two methods for cleaning a soldering iron tip. My favorite is to use a brass sponge. You can see this one is from Weller, and I actually got it at the same time I got my soldering iron. This not only cleans the tip well, it also won't cool the tip down like a damp sponge would. A lot of soldering stations actually come with a sponge, and I used to use one for a while, but unfortunately they don't last very long, so eventually I ended up switching to the brass sponge and have really fallen in love with it. Now you can see here that the tip has started to oxidize a little bit, basically just from being in the air and being hot. So to clean it, you just scrape it down into the brass sponge here, and it really does a good job brightening the tip and removing the excess solder and all the oxidation. This allows for a better heat transfer. So now we're going to demonstrate the insertion of standard through-hole components. I've got some 4.7K resistors that need to go onto the circuit board. First, I'm going to demonstrate how to cut the leads, then how to bend them and insert them into the board, and finally, how to solder them. To cut, I like to do 3 at a time using diagonal cutters. You snip them, turn them over, do the second snip, then set them aside. Now I have 3 of these resistors cut. Let's pull one. Now to bend the leads, you can hold them up against the circuit board, and you can see that you've got about 1/8 of an inch on either side of the resistor before you need to bend it. We'll take a measurement there and bend it with the needle nose. Then bend the second lead, then just insert the leads into the holes. Now let's get the other 2. Okay, so now we have 3 resistors inserted into the board. What you need to do next is turn the board over, all while holding your finger over the resistors to keep them from falling out. Then you take your needle nose and spread the leads apart a little bit to keep the resistors from falling out. So now we're going to get out our soldering iron. And you can see here that I have a fairly fine spade bit. There are smaller ones available, but I like to use ones like this for these kinds of through-hole components. Now often, when I get kits back from people who are having problems, I look at the solder joints and it's clear that they only held the soldering iron on the lead of the component, then just touched the solder on the lead and not the soldering pad. The secret to a good solder joint is to make sure your iron touches both the lead and the solder pad on the circuit board. You apply a little pressure, get the heat transfer, and then take the solder and touch just a little bit to the side of the iron, and you can see the solder flow right down into the hole of the solder pad. Now that's a good solder connection there. Even though you don't have a lot of solder, it flowed down inside the hole itself. These are plated through holes, so as long as you've got solder all the way around, it's a very good solder connection. Now I'm going to finish off these last 5. Okay, so there are 6 joints for those 3 resistors. Once again, notice that there's not a lot of solder, but it's flowed all the way around the circumference of the lead, and that it, for lack of a better word, has been sucked down into the hole around the solder pad. This makes for both a good mechanical and electrical connection. Now I'm going to demonstrate soldering a multi-pin component. The premise here is that once you get all of these pins soldered, it's almost impossible to desolder and get the component off if you've placed it in the wrong configuration or orientation. What we see here is a 40-pin integrated circuit socket. This is the socket that holds the microcontroller for the antenna switch. One thing I want to point out is that the socket, as well as the microcontroller itself, must be oriented correctly. You'll see on this end that there's a little indentation on the socket, and you need to make sure that that matches the indentation on the silk screening of the circuit board. With that inserted correctly, what we'll do is hold it down with our finger and flip the board over, making sure that all the pins stay inserted. You can see that the pins are still protruding through the holes. So what we're going to do is solder one pin and one pin only. I like to do it in the middle of the row of pins, just to hold the component in correctly. Then we're going to turn it over and double check to make sure the orientation is correct, after which we'll turn it back over and solder the rest of the pins. We also double check to make sure that the little indentation on the socket matches the indentation on the silk screening on the circuit board. It looks like we're good, so let's turn it back over and solder the rest of the pins. The best way to do it, again, is to hold the tip of the soldering iron on the pad and pin, add a little bit of solder, then what I do is hold the circuit board down so it's flat and the socket is flush up against the circuit board itself. Another type of multi-pin component is the DC power socket. The critical thing is making sure that the socket is perfectly aligned with the silkscreen outline on the other side of the circuit board. If it's not, then the socket itself won't fit in the cutouts in the back of the enclosure through which these sockets protrude. So real quick, I'm going to show you how I'm going to solder this one lug here first, then we'll turn it over and make sure that it's aligned correctly. If it's not, we'll then reheat the solder lug, all the while attempting to reposition the socket itself. Notice that I have the lugs positioned so that they're perfectly centered in the holes that I've cut out. This gives us a good chance of having it positioned within the bounds of the silkscreen outline. So very carefully, I'm going to hold the soldering iron down so that it touches the lug and the solder pad. We'll hit it with the solder and let it flow all the way around. Now we can see that the solder lug has moved around a little bit, so let's see how much it moved. We can turn it over and see how it aligns. So that looks pretty good. You can see this is pretty straight and centered between the lines, so I think we've got it. So let's turn it back over and solder the other two lugs. Alright, that does it. Let's double check. Yep, perfectly centered and straight, so this will fit really well into the back of the enclosure. So here I have the 5-volt linear voltage regulator, which I'm going to be inserting right here. Two things. First, you're going to want to make sure that the tab you see here matches the facsimile of the tab on the silkscreen. If they don't, then you're going to have a big problem because you won't be getting 5 volts out of the regulator. Another thing is that, while it inserts, it's hard to hold it in because it's very loose. The footprint is very precise and it slides in and out pretty easily. A trick that I do is that I'll take the needle nose and just slightly spread the pins apart. Then when I insert it, there's a little pressure on the sides of these pins, which is enough to hold the component in and keep it where you've placed it. I like to have these off the board a little bit for two reasons: heat dissipation, and to give you space if you need to troubleshoot later and touch a multimeter lead without having to go to the underside of the board to reach the pins. Now we're just going to solder these. It's a pretty simple solder job. Just clean the tip, then once again hold the solder tip on the pad and the pin, touch the solder, and let it flow. These are pretty thick pins, so when you're cutting them, make sure you hold your thumb over the pin or it might fly off and hit you in the eye. This also gives me a chance to highlight the clippers I use. These in particular I really like because they're specialized for cutting leads on circuit boards. They're a little angled so you can get them up against the board like this and cut very closely. You can find them pretty much anywhere tools for electronics are sold. Now we're going to demonstrate another heavy-duty soldering type, which is the center conductor of an SO239 RF connector. You also have the lead from the 100K ohm metal oxide resistor in the center of the connector's solder cup. Again, the trick is to get as much heat transfer as possible as quickly as possible. To do that, I'm using my 60 watt Weller soldering iron, which has a broad spade tip. So I'm going to place the tip of the soldering iron so that it's touching the lead of the resistor, the solder cup, and the solder pad on the circuit board. Touch the solder there and let it flow into the solder cup. Then keep feeding it since you want the whole cup filled. When you're done, you can lift it up and see that the solder has flowed all around the solder pad, the connector's center conductor itself, and the lead of the resistor, which means you have a good mechanical connection. Here I'm going to demonstrate how to solder multiple wires into a heavy solder lug. One of the problems with this is getting enough heat transfer onto the lug so that it also heats the leads of the components, allowing for a good solder flow. As you can see, this is a number 14 solder lug, and I have these 4 100K ohm metal oxide resistors. You can see the leads are fairly thick on these. Another thing to note here is that I'm using a different soldering iron than I would normally use to solder circuit boards. This is a Weller 60 watt soldering iron, and it has a large spade bit on it, which allows it to transfer a lot of heat quickly. So let's get this tip cleaned off, make it nice and shiny. The trick to this is to get as much heat transfer as possible. The best way to do this is to start with the tip of the soldering iron and put a little solder on there. The solder itself helps with the heat transfer. Hold it to the side of the lug so you can get as much surface area of the iron on the lug as possible. Then hold it there for a little bit. You can see that the solder will start to melt. I'm not touching the iron itself, I'm touching the lug. As you fill that lug up, it transfers that heat to the leads of the resistors, which means that when it cools, it's not only adhering to the resistors, but to the sides of the lug itself, making for a good solder connection. You see how quick that was? The secret is to start out with a little molten solder on the tip of the iron and hold it in against the lug. That transfers the heat really well. Here we're going to demonstrate soldering a multi-pin relay to the relay switchboard. One of the best things to do with multi-pin relays is to try and get the pins centered in the holes, which makes it a lot easier to remove the relays later if you have to. That way, when you use your solder extractor, we call them solder suckers, it'll suck all the solder out of the hole and the pin will be completely free. First, I'm going to solder one of the pins, doing my best not to move the pin or the circuit board. This will hold the relay in place. Notice that I have the soldering iron tip on both the pad and the pin, so I can have good heat transfer and just enough solder that it's sucked down into the hole itself. Now we're going to solder the rest of these pins. One thing you need to know is that these are very heavy traces that carry a lot of RF power, so it takes a while for the trace to heat up and the solder to get sucked down. Make sure you hold the soldering iron tip there long enough for the solder to flow down into the hole itself. So let's finish the rest of these pins. Another tip here is that since the trace has had time to cool down, we need to let it heat up again before finishing the solder. It's best to finish the pins on the same trace one after another because the trace itself stays heated pretty well. When we go to the second one, you can see that it goes a lot faster. Here I have a power switch and a cable that goes into the power switch connector. However, before the wire can be connected to the solder lugs on the switch, it needs to be tinned. The best way to do this is to hold the soldering iron under the wire to heat it up, then just touch the wire with the solder so that the solder can flow into the strands. I like to flick it a little bit to get that extra bit of solder off. Now that it's tinned, you'll be able to wrap the wire around the solder lug to get a good mechanical connection. So as you can see, I've wrapped the wires around the lug so I have a good mechanical connection, which is always good to have before you solder since it makes for a better, longer lasting connection. First I clean the tip of my iron, then I hold it down here. I try not to touch anything with the side of the iron since that could melt the insulation on the wires or even the switch itself. Hold the iron so that it touches the wire and the lug. Then use the solder to touch the hot lug after it's been heated by the soldering iron, and you can see that the solder just flows right around the wire and the lug. Let's repeat this process with the red wire. We're going to insert the wire. Take the needle nose pliers, wrap it, and squeeze. That makes a good mechanical connection. Once again, I clean my soldering iron tip, then repeat the process we did on the first wire. Alright, 2 good solder connections. Now we'll put the heat shrink on. Alright, that's it for today. Hopefully this gave you a good enough understanding of soldering that you'll be able to begin assembling any electronics kit. Thanks for watching.